Hi everybody, this is Mr. C, and we're going to make another Stellarium video here to go over some of the things we went over in class on Thursday. Now, I probably won't make these little videos for every single thing we do in the planetarium, but early in the quarter I wanted to make sure to go over some of these things just to make sure we're clear on all of these basic concepts. So I assume you've seen the last couple of videos that I posted, where we looked at how to download the program Stellarium, and we looked at how to use some of its basic and advanced controls to simulate the sky in the same kind of way that we do in our planetarium. So here I want to go over some of the basics that we talked about on Thursday, using Stellarium to review these. So I've got Stellarium up and running, and it's right now I'm recording this at about 5:19 in the afternoon on January 11th. So this is what the sky would look like outside if there weren't any clouds. The sun has just set over here near the western point in the horizon. Here the computer is showing us that this little point of light that is just starting to become visible, that's the planet Jupiter. There isn't a whole lot else that's out right now because the sun has just set and there's a lot of scattered light in the sky. Now here's a really basic thing to review, and you'd be surprised how many people don't fully understand this, and that is, why do we have day and why do we have night at certain times of year? Well, we can illustrate that, not at certain times of year, certain times of day. We can just illustrate that by clicking the atmosphere on and off. We can take atmosphere off, we can even take the Earth off, and now we see that the sun has just gone below the Earth, and that's getting blocked by the solid body of the Earth. So it's the atmosphere scattering light, and it's the Earth blocking the sun that gives us this twilight. Now let's run time forward a little bit like we did in class, and we can start to see now the stars are coming out, and we can look at more of the things that are in the sky. The other day in class, we also saw the moon. That was one thing that was up there. We'll save that for some other videos here. Okay, so we've got stars coming out, and we had some basic questions. We said, are the stars evenly distributed? And we can see they're not. In some parts of the sky, there's a long angular distance between stars. Remember, we talked about distance on the sky versus actual distance in space. And the distances on the sky, remember, were measured using angular distances. For example, we could use this computer program or a star chart to measure the number of degrees of distance from, say, Betelgeuse to Bellatrix, or Bellatrix to Aldebaran. And remember that trick using your hand to measure 15 degrees on the sky. Okay, so that's the idea of distance on the sky, and we can see that the stars are not spread evenly around. Here, for example, are a couple of nice star clusters. Here's one called the Hyades, here's another called the Pleiades. This star cluster here, for example, is a few hundred light years away. That's beyond the distance of all the stuff we'll talk about in this class, but it's an important basic astronomy concept to look at what all's up there in the sky. We also had this band of light, that's the Milky Way, which is the galaxy that we live in seen from the edge. Because we live inside it, we can only see it in an edge-on view. Okay, we talked about colors of stars. We could see that some stars, like Betelgeuse or Aldebaran, these are redder, or at least more orange in color than something like Bellatrix or Rigel, which is more blue or white. Again, that's kind of an Astronomy 10 thing, but it's another basic astro thing that's worth going over. We also asked, what else is there in the sky? And this is where the planets, the subject of our class, really start to come in. Here we've got Mars rising. Notice that it's over near the eastern point on the horizon, and so that's the part of the sky where things rise. We've got Mars coming up like that. We can speed time forward a little ways and watch Mars rise higher and higher into the sky. We see something else coming up called Vesta. That's an example of an asteroid. Vesta is one of the larger asteroids out there, and we'll talk some more about those as the quarter goes on as well. So here we reviewed the basic things in the sky. We see stars of different brightnesses, different colors. We see them spread out rather unevenly across the sky. We saw the moon, and we also see things like planets and asteroids. Now, you might be wondering, how in the world would someone look at the sky and at a glance know that that's Mars? I happen to know that, but only because I've learned it and memorized it. But there's another way you could figure this out, and that is by watching the sky over a long period of time. And this is where the word planet comes from. It comes from an ancient root meaning wanderer. Here's a way that I'm going to try to illustrate that. I'm going to use the Alt key, and I'm also going to use keys like minus sign, equals, left square bracket, and right square bracket. And I can jump time backward and forward using a system that's a little bit different than the way we've done it before. We've seen the L key, we've seen K, and now I'm going to move time in such a way that the stars won't seem to move relative to the horizon. But we are moving time forward, which you'll be able to see with our time readouts down here. So I'm going to move time forward a little ways, and notice we can see Mars move. Notice also that our dates are changing here. In fact, I'm going to turn off the atmosphere so that we don't get daylight in the way, and I'm going to continue moving time forward like that. Notice there goes the moon whipping by. There are Mars and Vesta moving along. Notice also that Mars is starting to stall out, and something very strange is happening. It's going the other way. Now, the reason the grass looks all lit up is because this would be daytime. I've just turned off the atmosphere. Now we see Mars heading back the other way. And there goes the moon. Every so often the moon just comes whipping by like that. It's these motions in the sky that told people thousands of years ago that there was something different about some of these points of light in the sky. And it's all of these apparent motions in the sky that we want to sort out over the next couple of classes. People like Galileo and Kepler and Copernicus and Newton, these are the people who figured out what's really going on with those moving points of light in the sky. So that'll be a big part of what we do in this class.